So, hey guys, welcome back to Azure Architected Framework, a design framework that strives to encourage architects and development teams, to build software that is conformant or within the guidelines that they specify from cost, security, operational excellence, performance, and reliability perspective. Today, we're talking about performance efficiency, and under performance efficiency, what we are looking to essentially is how well does your solution perform, right? So the idea is you need to be able to negotiate the realistic targets, right? We are not going to build a lightning fast software because lightning fast is actually not really that achievable, right? But there is targets to say, cool, I want you to back up, I don't know, daily transactions or monthly transactions in this particular speed, right? If you say a backup in Azure, for argument's sake, create a backup and the backup must happen in 5 milliseconds, right? If the database is 50 gigs big, will that happen? That's the realistic element of it that we need to negotiate based on the tools that we have and the budget that we are given. Provide enough for anticipated demand, right? Black Friday, I think we've had this a lot in the market where payment gateways are having the best times of their lives when it comes to Black Friday, right? There's talks about have enough resources for the anticipated demand. At the beginning of the project, the customer says, cool, we have 1,000 users, concurrent users that are going to hit the system at any particular given point in time, right? When that happens, you kind of need to test for the demand. You need to test for the requirement and make sure that you have enough resources that says, cool, if an API response must respond within, I don't know, 200 milliseconds, implement something that speaks to that or test against that particular requirement and see if the tools that you have actually match that, right? If you can't really prove it out or kind of suss it out, there is no issue in building a POC. It is actually recommended to build POCs to actually prove these concepts that you're coming about, prove the requirements against the reality that's out there, right? And the other idea of performance here is mitigate degradation over time. People that I normally hear in here, they would say, cool, our database used to have one table, one stored proc, one index column, and now it is a big database. We have thousands or hundreds of stored procs that are running in the system, right? That kind of talks about features that we add onto the system, the maturity of that system at that particular point, right? Then what we're talking about here is degradation over time. Those kind of things actually happen, and we kind of need to look at processes that consume our resources or compute and make sure that they actually still give us return on investments, right? Make sure that they are still providing business value. If they are not providing business value, we kind of need to basically get rid of them, right? And this is a conversation that with business, it is an iterative process that we need to go into, right? So just be on the lookout of that. Final point is a loaded one where I say refine, reduce, repurpose. Right? Refine, I'm talking about consistently look at your designs where there is bottlenecks, where there's issues with your actual architectural design. Don't be afraid to change it. Right? Continuously revisit the ideas that you've initially had because ideas change over time and assumptions change over time. So don't be afraid to change that. Reduce simply means reduce your usage based on your learnings over time, right? We said 1,000 users, but in reality, we're getting 100 users uh, a minute or 100 users at that particular interval that we agreed on. Do we still need this quantum computing resource or do we need to downscale it? So reduce if necessary, right? And on the idea of repurpose, I speak about something very critical. We always say, cool, for us to be able to achieve this feature or to add this, I don't know, security scan or whatever onto your system, we need to upscale. And if you upscale, there's cost implications with that because obviously you're changing your pricing tiers and all of that, right? But in other cases, you find that you are not using your compute to its maximum or to what do you call acceptable high rates, right? What you can then do is use that compute that's there to enhance other pillars that are involved in this particular case, right? For example, you can increase reliability on your system by basically start adding things that give you matrices that allows you to achieve real reliability, right? You can start adding things that do, let's say, your alerting and all of those kind of things. If you don't use what is already built on the platform, you can then use that what you call compute to actually trigger this custom alerts or whatever the case might be. So that is pretty much what this pillar talks about on a very high level. So some of the things that you can think about from a performance perspective, let's say for example, this is a very good example. You have a vendor that cannot process your requests at the per second rate, right? And you need that data at the per second rate. How do you then achieve that? Can you talk to business? You say, cool, the vendor cannot give us this. What do we do? They can say, okay, cool, we don't need the data in real time for argument's sake, right? That means you can have a copy of the data, copy the data into your own data warehouse, into your own database or whatever with the right level of resources that you require. Then basically once you have that copy, you can then control resources or upscale, downscale that particular portion of it, right? You upscale it to your requirements and you actually define the implications of doing something along those lines. And other cool things that you can start doing in this kind of performance stage, decoupling your system is another point where your backend heavy lifting processes sit in a different system and your kind of lightweight customer facing solutions sit in a particular portion. This talks to segmentation as well. But then remember, when you start doing segmentation, there is a drawback here where when you do segmentation, you have an implication on security, where security now needs to check multiple portions of the system, right? If you add segmentation in this particular point, you might stand to lose latency between or cross system authentication, network latencies, and all of those kind of things might come into play. So factor that in as well when you do those kind of, segmentation, splitting of systems, and all of those kind of stuff. Cool. Have a good one. This was a pretty decent time kind of range that I'm planning for these videos. So thank you very much for tuning in. I am hoping to hit the record with the next video and make it 3 minutes. If I don't make it 3 minutes, just remind me on the next video in the comment sections and let me know to reduce my video times. Thank you very much.